report. Our topic is about UAV tracking system. And I am Cao Yang.
I'm 张敬贤。
I'm 陆琪。
肖张。
In information age, many people choose to install surveillance cameras in their house, which can ensure their own personal safety and property safety. And the government also installs surveillance camera in the street. If the surveillance camera can really keep a watch out everything of the street, the answer is no. Because of the surveillance cameras are installed in a fixed place and the surveillance cameras cannot rotate. So it results in blind spots which imperils people's safety and seriously. Our team come up with a good idea to eliminate this disadvantage of the traditional monitoring system, which is UAV tracking system. UAV tracking system and the computer version are now two of the most popular technologies. So we want to combine them to create a cool application named the tracking system. The UAV tracking system powered by computer version algorithm will be able to identify a specific person from a complex background and track its target. With the UAV tracking system, people will no longer worry about the dangers from blind spots of the traditional surveillance cameras. This is a disadvantage of the traditional surveillance systems. It has a blind spot and it can just send little information. It cannot track target and just can observe only one perspective. This is our UAV tracking system's advantage. It can save more information and track target and report quickly. And we can give the instructions to our tracking systems by our personal computer. Next, I will introduce our design process. Now we have completed the basic operation test. Next, my teammate Lucy will introduce the project requirement and assessment metrics.
Next, I will introduce the project of requirement. We divide our requirement and assessment into 6 parts. And next, I will introduce these 6 parts. The first one is hardware requirement and assessment. For the requirement of hardware, our project will use Port AR Drone 2.0. Why we choose this device? It is easy for us to write the program, and it can easily connect a PC with Wi-Fi. For the assessment, the Parrot AR Drive 2.0 can work well, and the connection with PC by Wi-Fi is stable. Next is software requirement. This project is based on robotic operating system. For the programming, we write code in Node.js. For the assessment, the code will work as our designed. The third one is recognize the requirement. We plan to achieve the recognize of the target and the recognize of the target's movement. We will use OpenCV database to achieve the recognize of the target. As for the assessment, 90% of successful rate is our goal. If we got that goal, we will still working for the 95 to 99%. The fourth one is checking requirement. After recognize the target movement, the PC will do some adjustment according to the movement data sent by UAV, and then PC will send the adjustment to UAV. For the assessment, PC can successfully get the information from UAV, and while UAV can get the adjustment from PC and response. Fifth one, reliability. For the requirement of reliability, we will test many times and at least 100 times to make sure the reliability. As for assessment, we will test in different environment and reset the settings before test. Last is report. GPS device is needed in the part. Therefore, we can record the flight paths and send to the user timely. For the assessment, is that users can receive the moving track timely. Next, my groupmate will introduce the issues of concern.
Now I want to talk about the issue of concern we will meet in future design. Those issues may happen in recognized part and the track part. Issue of concern is about recognizing those parts. We may meet three issues of concern which will inhibit the success of our project. The first is the programming about the recognize. As we can see in this PowerPoint, our object is to recognize the back view of the target based on ROS, and it might be a little bit difficult to us to achieve. And the second issue of concern we might meet is recognize this side view of the target, because our UAV recognize is based on recognizing the back view of the target. When the target suddenly turn left or turn round, it is a challenge for our UAV to recognize the target. And the third issue of concern is recognize of the target when the target quickly change his back view. For example, we can imagine the situation where our target quickly take off his coat, and then the change of his back view will increase the difficulty of our UAV recognize. Another issue of concern is about track. We consider condition where our target hide behind a tree. Our UAV would lost the target, and then how to catch our target again is the issue of concern which might inhibit our project. So there are all issues concern we consider about currently. Then I will introduce the status of our project. As we can see in this PowerPoint, the Gantt chart, this semester we finished the first and the second step of our plan, and we select the Parrot AR Drone 2.0 for our UAV of our senior design, and we successfully achieved the basic flight programming in our computer and control our UAV's flight by programming those. Those are prototype of our project. After our coding program, it about 90% of our project will be finished, and then we will be ready for our project demonstration technical exposure in March. And finally, this is a video we control in our UAV by computer.
Okay. First, the Parrot AR drone can only be controlled by an official iOS application provided by the company. And we then play around with the SDK and protocol. After hard working, we can now write program in Node.js running environment and send it to drone through Wi-Fi. That's to say, we can build our own application from scratch. You can see from the video that the drone first take off, stay a fixed distance away from the ground, rotate a specific angle controlled by the program, move forward a fixed distance, and finally land on the ground. The movement itself seems simply, but any complicated movement can be divided into the 5 operations. We can package the programs separately, and we will call them in the applications like recognition and tracking. Next, so since we have already made it clear how to control the UAV with Node.js commands through computer instead of using the controller given by Parrot AR Drone controller, we'll move to the stage in introducing RS, or namely the robot operating system, to our project. The RS is the platform used to develop robot applications. It provides an integrated development environment. We can employ RS to help us complete our UAV movement control, target recognition, and tracking. For the target recognition and tracking tasks, the key point is the image processing based on machine learning. Since it's hard to complete the algorithm all by ourselves, we're going to use OpenCV directly and combine it with the movement control to build our 3 main functions. And you can see now we are starting our RS and try to introduce it to our project. However, we found that OpenCV doesn't provide a RS version. This is not out of our expectation because our RS is not a real operating system. It's like just a framework. So what we are working on now is to complete a transformation mechanism, which means we are going to change the image type from sensor MSJS to CVMAT. The CVMAT is a special image tab in OpenCV. You can see from the plot here, we have built a CV bridge module. It can change the RS image to the CVMAT. So next, after we finish our CV bridge in the next semester, we are going to complete our movement controlling our algorithm in RS. And then we will install OpenCV in RS and process image with the help of it. And we can recognize our target. Then we combine the recognition and the movement control. As you can see in the above the slides, we can complete the basic operations. So we can just combine them together and achieve the tracking function. Finally, we will add some extra features like to recognize the person behind a tree or something like that. That's all. This is our presentation. Thank you.
Thank you.